excited to be here. I'm Jessie Auguste. I'm a software engineer at CyberSafe. I co-host a podcast called Glowing in Tech, and I'm a member of the Open Web Application Security Project. So today I want to talk about, well, this stat I always find really shocking and I think exemplifies why I think we need to talk more about security. 81% of developers have knowingly released vulnerable applications. And I don't think this means that people don't care. I don't think it means that people aren't trying. I just think it means that the security landscape and developing secure web applications is an overwhelming space, and it can be a big can of worms. It's really hard to know where to start, and people often don't consider security until the end. So I'm going to be talking about a few things we can implement when we're building JavaScript applications. And so to start with, secure software development is developing computer software in a way that guards against the accidental introduction of security vulnerabilities, because defects, bugs, and logic flaws are consistently a primary cause of commonly exploited software vulnerabilities. So I believe that we all have responsibilities as developers to be user-focused and to think about how we're building securely in a way that means that the people who are using our technology, our apps, our websites, are protected, and we're continuing to provide an ongoing effort into making sure that people's data and their behaviors are protected from unauthorized use or harm. So I'm going to try and do this as quickly as possible, 5 ways to hack-proof your JavaScript. So start with cross-site scripting, and it's the number 3 in the OWASP top 10, so it's a really important one. And it's essentially, well, it's a misnomer to begin with, because its name comes from when early versions of the attack were talking about stealing data from cross-sites, but it has extended to also include any form of injection. And it's essentially causing untrusted scripts to run in a user's browser. So what can we do to prevent that? What are some of the things we can do? And one of them is input validation. So any website that requires a user to fill out input fields can also be used maliciously by attackers. And so it's really easy for attackers to automate the way to find these vulnerabilities in your applications. All they have to do is enter invalid inputs on a website in bulk and then determine if your application has that vulnerability. So we should make sure that we're considering these techniques to make sure that we are only we're only receiving expected characters. This is an example of avoiding input validation, because you're not actually letting the user input data, but you understand the point. It's making sure that we're cleaning and sanitizing what does go in. Next, we're talking about HTML sanitization. So we saw some awesome versions, code editors in the browser, which is amazing. And we more commonly might see markdown editors as part of an app or a website. And it's really important to make sure that we are sanitizing that input and essentially creating an allow list of what we will and won't allow a user to have when they're creating HTML blocks. And that's essentially allowing styling, but making sure we're not allowing things that can be more dangerous, like the on-click attribute and things that would allow injection and malicious attacks. And third, I think I'm kind of preaching to the choir here, I'm sure, but utilizing modern frameworks, but together with this, also considering the gaps that they may have. So modern frameworks are built in a way that kind of provides a batteries included approach, and they're doing a lot of the thinking for you in terms of making sure that you're building with security best practices in mind. However, there are also parts within different frameworks where there are some gaps. So making sure that you're considering where those might be. Angular has the bypass security trust as function. React has the dangerously set inner HTML without sanitization, which can allow HTML to be submissive without sanitization. So like using these frameworks, but also taking the time to look at where these frameworks might have gaps. And then I'm going to talk a little bit about some DOM-based vulnerabilities. So this is DOM-based cross-site scripting is a vulnerability that allows attackers to inject malicious payloads into a web page by manipulating the client's browser environment. And this can be a little bit harder to detect with traditional scanning because the malicious payload is stored within the client's browser environment. It makes it more difficult to detect. So obviously, we love using the DOM because it means that we've got a powerful and flexible way to modify elements within a document, but that makes it quite a lucrative way to use it as an attack vector as well. So number 4, on the back of that, is to enforce a content security policy. So it's an additional layer of protection. It allows for safe methods of DOM manipulation. And I don't know if you can see in the little diagram, you're essentially making sure that in the header you're setting, again, an allow list of ways that you can have modifications from the server side of the assets that you have on the client side of the browser. And then number 5, we've got implementing privacy by design principles. So this one, I think, is one of the most important, even though it's not necessarily about the code itself. It's about making sure that you're thinking about the user and you've got them in mind when you're building. So secure code is also about what you're storing. It's not just about what you're allowing the user to do, but what you're keeping about them. And so by building with these privacy by design principles, you're really making sure that even in the initial stages, the design stages of what you're going to build and the app that you're trying to put together, you're considering the user's needs and what exactly we need to store about them. Because sometimes it can be really easy to store things that aren't necessarily useful for that user or that the user might not necessarily consent to. So considering privacy by design from the first design stages and throughout the complete development of a process can make sure that we're no longer just thinking about data protection at the point that we're storing it and the website and the app is live. We're actually making sure that from those first stages, the things we're storing are useful for the user and they are safe. And then to summarize, security is an ongoing process. We have the tendency to leave it all to the security teams at the end and the pen tests and things like that, meaning that we're submitting that vulnerable code and then not finding out until later, and then it's kind of the security team's job to deal with it. And I think that we should try to collaborate a little bit more, especially when we're building the front end and we're using JavaScript, making sure that we're working together as a team and sharing that responsibility. I think testing and scanning are absolutely really powerful ways to make sure you're automating what you can catch, because you're not going to be able to catch everything no matter how thoroughly you think things through when you're building. And also staying curious. I think it's really easy for security to become an intimidating and difficult to manage topic, but the more we stay curious, the more we approach these things with a little bit more fun than necessarily like fear, it makes it a lot easier to kind of learn things and make sure that we're continuing to implement and keep up to date with the threat landscape as that evolves. So, yeah, that's me. Thank you very much.
Gorgeous. Thank you very much. That was also very devastating.